Welcome back to my YouTube channel. So in today's session I'll be explaining about Heisenberg uncertainty principle. So let us know what is Heisenberg uncertainty principle. This is the introduction. As you all know, my name is Sansana and I'm pursuing my first year engineering in Sri Venkateshwara College of Engineering, and the section which I belong to is Chevrolet. The subject which I'm explaining today is physics and the topic is Heisenberg uncertainty principle. Introduction to Heisenberg Uncertainty Principle. The Heisenberg Uncertainty Principle is a fundamental concept in quantum mechanics. It was proposed by Werner Heisenberg in 1927. This principle states that it is impossible to simultaneously know the exact position and momentum of a particle. Here in this picture, you can see he is Werner Heisenberg. He has given the principle stating that it is impossible to simultaneously know the exact position and exact momentum of the particle at any instant of time. This was a fundamental concept in quantum mechanics, and it gave a wide application in quantum mechanics. It was also the base for the quantum mechanics. So, what was the mathematical formula of this Heisenberg uncertainty principle? The Heisenberg uncertainty principle can be mathematically expressed as delta x. So, the formula here it is given by delta x into delta p is greater than or equal to h by 4 pi, where delta x represents the uncertainty in position, delta p represents the uncertainty in momentum, and h is the reduced Planck's constant. Here you can see the equation also can be written as delta x into delta p is greater than or equal to 4 pi, which can also be written as delta x into mv, which is m is mass and delta v is the uncertainty velocity, which is greater than or equal to h by 4 pi. It can also be written as delta x into delta v is greater than or equal to h by 4 pi m. Next, implication for measurement. The Heisenberg uncertainty principle implies that there are intrinsic limits to accuracy of measurements in quantum mechanics. We cannot determine both the position and momentum of a particle with arbitrary precision. So here it says that exact position and momentum of a particle cannot be determined exactly in an arbitrary precision. So when electrons are moving in an orbit, its exact position and momentum cannot be determined at the same time. Application in quantum mechanics. The Heisenberg principle is at the heart of many quantum phenomena. It helps explain why electrons exist in specific energy level around an atomic nucleus. So as I told you before, this Heisenberg uncertainty principle plays a very important role in explaining quantum mechanics. So it has a wide range of application in quantum mechanics. I have listed few applications as you can see in the picture. The first one is quantum uncertainty, and the second where it is used is wave and particle duality. The third is wave interference. Next is quantum entanglement, decoherence or coherence, and superposition. In all this, in for explaining all this phenomena, we use Heisenberg uncertainty principle. Next is experimental verification. The Heisenberg uncertainty principle has been experimentally verified through numerous experiments. For example, this famous double slit experiment demonstrates the wave particle duality of a particle and inherent uncertainty in their position and momentum. As we all know, double slit experiments where there is a two screen used, one is the large screen and the other is the split screen. Using this, the waves which pass, so using this even the uncertainty principle can be explained. Heisenberg's metric mechanics. Heisenberg's formulation of quantum mechanics, known as metric mechanics, provides a mathematical framework for understanding the Heisenberg uncertainty principle. In metric mechanics, physical quantities are represented by matrix and their uncertainty is described by commutation relation. Here in quantum mechanics, the matrix is usually represented as 0 and 1. So P and X are represented as matrix for infinite dimensions. P Px is not equal to Xp. Px minus Xp is equal to minus I h by 2 pi, which is the commutation relation or quantization condition, which was given by Heisenberg as matrix mechanics. Importance in modern physics. The Heisenberg uncertainty principle is a cornerstone of modern physics and has profound implications. It challenges our classical intuition about the determinism of nature. Next is the conclusion. The Heisenberg uncertainty principle states that there are limits to the precision with which we can know both the position and momentum of a particle. It is a fundamental principle in quantum mechanics and has been experimentally verified. So the mainly the Heisenberg principle, uncertainty principle, explains that there is we cannot determine the exact position and the momentum of a particle at any instant of time, and it is also very experimentally verified using different experiments, and also it is a fundamental concept in quantum mechanics, and it is also given the formula where we cannot accurately measure the position, but we can precisely determine the position of the electron and momentum of the electron. So this is all about Heisenberg uncertainty principle. Thank you all for watching my video. If you like the video, please do like, share and subscribe. Thank you all.